Login accepted.
Hey Devoxx, can you hear me? I hope you can. Thanks for having me. My name is Sebastian Gębski. I work for a company you may have heard about us. It's called Amazon. We used to sell books. Right now I'm more into meteorology business. I work with the cloud. And I mostly help, on a daily basis, I mostly help startups with their journey to success. And those startups operate on AWS. Many of them use Java, use JVM languages on a daily basis, and I'm actually quite surprised that even if they do it and they are very proficient about it, in some cases they don't know about those tiny details that can make the difference for them. And those tiny details are the way that infrastructure people in AWS in general, have made Java developers' life a little bit more pleasant by utilizing the advantages and strengths of JVM and Java and adding Java developers a little bit more, something a little bit more, something a little bit better. Sometimes those little tiny details that benefit only given platform like Java or JVM can make a lot of a difference. So today I've decided to collect some very interesting, I would say, features, capabilities, options that you as Java developers or JVM developers who work with AWS should know about. So this is what this talk is about. Here is my contact information. So if you have any questions after this talk, if you'd like to talk about Java on AWS and AWS in general or anything else, feel free to use this contact information. By the way, you may see this little yellow icon down there. I'm a part, like personally, not professionally, I'm a part of a small group which is called CTO Morning Coffee. It's an online group where we do discuss topics that are relevant to senior technical leaders. Senior technical leaders meaning engineering managers, principal architects, staff engineers, CTOs. So we do this pro bono. This is not any kind of paid advertisement or anything like this. But if you are interested in such a conversations, because maybe you are already a senior technical leader or you are an aspiring one, feel free to take a look, because this may be something that you will find interesting. By the way, it's not just me. We have Wojtek Ptak, who is actually right now at stage 1, who is also the part of this small group. Anyway, back to our topic. Maybe let's set up some ground rules. So first of all, this is not an introduction to AWS. Sorry for that, or maybe it's good, I guess. So I will talk only about things that are specific to Java and JVM. So I will not introduce any specific services unless they have something which is dedicated for you. Yeah, so it may not be only dedicated for you, but there may be some quirks, there may be some optimization techniques, so something you should know about, something that will make a difference for you specifically. Maybe some tips and tricks. So it's supposed to be an engineering talk, and no marketing allowed, things like that. And in the end, you will tell me whether it worked or not. Was it an engineering talk or not? The plan is actually very simple. I will start with the basics, so the things that you should really know about. And if you don't know, then it's really, really bad. Then I will maybe talk a little bit about running functions with Java JVM code in AWS. Then I will move to containers, so what's specific to containers. Then maybe a little bit about developing on JVM for being deployed later into the cloud. And then some other stuff that doesn't belong any other kind of category. Great, let's start with the basics. So first of all, obviously there is an SDK. So you can reach out to AWS resources using SDK, and I guess every cloud provider has something like this. The important thing, and that's why I put this slide here, is that you may be still using SDK version 1, but there's SDK version 2. SDK version 2 is not just more optimized, better, faster, and of course will be maintained for longer, while V1 is probably already reaching its time. But it also has a lot of quality of life improvements, like, for instance, integrated retry and back of behavior. And of course, all kinds of different strategies when it comes to the access control with IAM. So if you don't use SDK version 2, it's actually an action call for you. You should change it. So this was easy. SDK for Java, everyone knows about it. But do you know that actually we do have an SDK for Kotlin as well? So there is SDK for Kotlin, and it makes sense. You can scan the code if you want to go there straight away. But the interesting thing about this SDK is that, yes, it's based on the same common runtime library. So in general, the core functionality is the same as in case of other SDKs. But in this case, it really utilizes the strength of Kotlin. So for instance, it does support DSL builders. And of course, all API calls are synchronous, and they run in coroutines. So that's the idea. Like, in many cases, actually, even if you do not use Kotlin, if you just use Java, for the sake of performance, you may be advised to actually go for SDK for Kotlin, just because in many cases it may be faster. So yeah, I just told you a little bit a few seconds ago that when it comes to the core functionality of this SDK, it's pretty much the same. In the end, it's calling, because it's the same resources in the cloud and so on. So this actually brings us to yet another tool that you may find interesting. The tool is called Smithy. It's an open source tool, and it's available for a long time already. And Smithy is an IDL. What's IDL? IDL is interface definition language. So if you want some sort of an example, for instance, OpenAPI is also very close to IDL. If you are an old-timer like myself, you can think about Corba. So the actual idea is that if you are working on a huge solution, for instance, like a huge distributed system, you may want to reduce your dependencies and have the dependencies that you need to have very explicit. And those dependencies, the services that you actually public for each other, they may be created using different programming languages. They may communicate over different protocols and in a different manner, synchronously, asynchronously, and so on and so on. So basically, Smithy is a protocol agnostic, transport agnostic, programming language agnostic, interface definition language that we in Amazon, in AWS, use to define those interfaces. And the power is not in this language. You can see it here. It's an invented language to define those interfaces. The power is in the tooling around. It's like with gRPC, basically, but on steroids. You can generate stubs, you can generate clients, and you can create them in different paradigms, for instance. So because this is, if you compare it, just like I did a moment ago, to OpenAPI, this is not transport agnostic. So it's actually a very powerful mechanism. Thanks to that, we are able to create those SDKs, like SDK for Kotlin, very, very quickly, because you don't have to use it only for the APIs which are available over the network, but you can also use it, for instance, to create SDKs. So in general, for large organizations which use many programming languages, which use many different paradigms of integration, this may actually be very, very useful, not only to make sure that you communicate in a controlled way, but also that you, for instance, can create automated documentation, that you can simplify contract testing and things like that. There's a nice page with some resources. You can see there how many open source projects have been already created to support this Smithy ecosystem. Anyway, so yeah, but we are still in the basic section, so stuff that you should know. This was just a digress. Anyway, yeah, you probably know that there is AWS Toolkit, and AWS Toolkit is an IDE extension, and there's version, for instance, in IntelliJ IDEA, which is very popular, especially for in the JVM world. And yes, it does have some specific support to JVM languages, also via so-called QDeveloper, and I will get back to this a little bit later. So it basically helps you to navigate cloud resources directly from your IDE. And not just the resources you have there, but for instance, if you use infrastructure as code with CloudFormation, you can see like what's the stage of the deployment, of the provisioning. You can browse the logs and all that kind of stuff. There's of course also a toolkit, for instance, for VS Code. Actually, I like this one a little bit more. There's a small image here in the middle where if you are really a fan of creating those serverless workflows with Lambda functions, step functions, and even bridge, you can actually visualize them because there's a dedicated language, and this visualization in VS Code is actually quite nice. As far as I know, it's not present in IntelliJ. Anyway, so yeah, you should just know about this. If you haven't tried it, I encourage you to do. There's yet another very basic thing that may be useful for you. I will literally spend 20 seconds on that. And this is Code Artifact. And Code Artifact is basically a managed repository. So in your case, it does work with Maven, it does work with Gradle, and it meets all the typical enterprise requirements like encryption or audit trail. And also, especially for the organizations which are to some degree regulated, you can have very easily configured, for instance, automatic download of the packages which are coming from the public internet. So you can control that. So yes, there is a service for that as well. So you don't have to set up your own artifact management service. Yet another thing which is probably known to you, I hope it is Amazon Corretto. So yes, Amazon does has its own OpenJDK distribution, obviously a downstream distribution. It should be clear. It has a no-cost long-term releases, so that's very important. It's also a default Java runtime for those services that require runtime. So if you are, for instance, asked to pick, because you are going to connect some Java code, and if you are asked for the runtime, you pick Java. Basically, this is your default choice, Amazon Corretto. Obviously, it's it gets all the certifications that is needed, and it's available on all the popular OSs. Yep, so these were the basics, the stuff that you should know. I hope you knew, but it was good to make this sync check. Let's talk about ways of running Java code in the cloud. Basically, there are two categories, functions and containers, the major two categories. Let's start with the functions. To understand a little bit specifics of running Java JVM code in Lambda, first we need to understand a little bit how Lambda works under the hood. So it's not as simple as just calling some sort of a function. Actually, it's a little bit more tricky. So first of all, it's all event-driven, so you get some event coming, and then this event is mapped to the form that is understandable by the front end of the Lambda. Front end is obviously not a user interface. It's just this component that registered the request, because obviously the request is not served synchronously. No, there are some small, tiny environments, execution environments running in micro VMs. So for the front end to actually execute the function, it has to have an available execution environment, which has to be prepared. So that's why we have this small internal queue. And here is probably where you already see the problematic part. So the problematic part is that when you don't have your micro environment, your micro VM, your execution environment ready, because to have it ready, of course, you need your package there, you need the dependencies, and you need the initialization already run. And it takes some time. So you don't want to do it each time the function is invoked. Because in fact, most likely your function is invoked several times. What kind of function is invoked just once? I mean in total, not in particular session. So that's why the tricky part here is the init part, because then you can invoke in a very, very cheap manner. And this issue is called a cold start problem. Cold start problem is the problem where you actually don't have an available microenvironment and you need to initialize one. And that means that maybe your function, the body of your actual function will run only in 10 milliseconds, but the actual initialization will take 100 milliseconds, which means that it's more than 10 times longer than you expected. So this is typically when we are looking for when it comes to optimizations. Because if we do some tests, load tests, performance tests at scale, you will see those aberrations, those initializations as a long tail in your distribution. And this can make an issue, especially if you have a very complex orchestration of those Lambda-based microservices. So this is typically when we are trying to optimize, and I will tell you a little bit about optimization specifically for you, for Java developers. Well, first of all, maybe let's debunk some myth. So if you are already running Java code in Lambda functions, typically the way you do it is you just use some framework, web framework like Micronaut or Spring Boot, and you just use the library which is dedicated, for instance, to running this function on AWS. Each of those frameworks has such a library, and you use typical web construct. So it looks like a controller, and it's your intuitive model of programming web interactions. So it's all cool. The problem is that you don't need it. Why so? Because it increases the size of your dependencies. So in fact, what you really need to run Java code in a Lambda function is those three libraries here. They are completely framework-less, and this is like the minimum footprint that you need to have. So the first one, Java core, basically it has the handler interfaces for the function, and the context object, because as I said, all Lambda invocations are event-based, and those events can have very different nature. So for instance, there may be a Lambda invocation because an S3 object has been uploaded, or maybe there was a specific request, right? So in this context, you already have the basic information. Then there is a Java events library, which extends this a little bit and adds more specific info for the AWS event sources. And finally, there is also a test library. So it's just a hint that in many cases, you may not need the web framework at all to write the code that you want to have in Lambda. Great. So yeah, as I said, optimization, when it comes to running Java, and not only Java in Lambda, you typically look for optimization of the init time. So you battle the cold start problem. And there are many, many techniques to do that, and you see some of them on the screen. The problem with those techniques is that not all of them are simple alike. Some of them are more complicated, require more work, and obviously also the results differ. So in some cases, you can speed it up 10 times. In some cases, it will not be that impressive. So maybe I will guide you very quickly through some of those optimizations. So the first one is actually very intuitive, but I put it here for a reason. So of course, when you run Java function in Lambda, you have to specify how big this Lambda will be. And the way you size it is you cannot say separately how many cores and how much memory. This is actually bundled. And yes, Lambda functions can have more than one core. So for some people, it's actually counterintuitive. Should I run concurrent programming within function? Why the hell not? Yes, you can. So the idea is that, of course, if you size it properly, so if you choose the proper option, it will probably run faster. But also, you don't want to oversize, over-provision. You don't want to waste resources because it will be too expensive. So how to do this? How do I right-size it? How do I really know? Should I use the profiler and verify how much memory is being used? Well, the good news, and this is something that you may not have heard about, is that there is the tool which is called Lambda Power Tuning. And what it does, it takes your code and it does the experiments. So it runs your code within all of those available configurations and it generates you a graph. So it pretty much tells you what is the function of how quickly it runs versus how much it will cost. So it helps you to make the decision how to right size your Lambda. That's a nice quality of life improvement. Another question which typically pops up, especially for Java, with JVM and all of those dependencies that can be actually quite heavy in many cases, is how should I do the packaging? How should I work with dependencies? So the answer is simple. You should bundle it all up together. You should create the Uber jar, and just because the single jar file will be faster to load. So that's important. One important thing to consider, and yeah, obviously for Lambda functions, you should really consider lighter dependencies. That's what I told you. That Spring Boot can be nice and convenient, and you may have a lot of experience with that. But it will give you an overhead that you may not need. Maybe just running with those free libraries it's good enough for you. And when it comes to like bundling, like don't reinvent the wheel. There are already plugins, there are tasks, and like feel free to use what is already there. It's a no-brainer, and you should not waste time on that. Tiered compilation. Everyone knows that the tiered compilation was with us for a long time already, but not everyone knows that in case of Lambda, especially if you want to optimize the cold start for the cold start problem, you should actually only use the C1 compiler. So yes, just like you can see on the screen, please do enable tiered compilation. It's actually turned on by default since Java 17, as far as I see here. But please specify that tier stop at level 1, at level C1. Yeah, not everyone knows that, especially for the microservice orchestration using HTTP, there is a dedicated library, CRT HTTP client, which have a much smaller footprint and very stable code distribution, and is actually optimized for that kind of scenario. Yeah, it's very simple to use. You just replace the client that you typically would like with that, and actually the benchmarks are quite impressive. And as far as I know, it's open source. And it has been created by Amazon for the internal purpose, if I remember correctly, but it has been open source and bundled with Corretto, I guess. Yep. That's something that you may have heard about, Lambda Snapstart. There was quite some sort of discussion last year, I think, about this. It's a new optimization technique that actually can speed up your Lambda functions, the need of your Lambda functions very significantly. And basically, you don't have to do anything to just enable it as a flag. So what's the idea here? The idea here is that in this case, you don't need to reinitialize the microenvironment that has been already created. Why so? Because the microcracker micro VM, what it does, after the initialization, it creates the snapshot of the memory. And it's able to automatically save this snapshot of memory so it can be restored later in case of the next execution. So it speeds up even more than in case of reusing the environment that is already there. And in fact, I haven't tried that, to be honest, but it's possible to customize it with Crack. We will talk about Crack a little bit later when I will get to containers. So how does it work? Yeah, it's super simple. So after initialization, there is pre-snapshot hook, which is optional, and then the snapshot is being created. So after the initialization can be also costly, right? So it really depends on what you do there. But then the snapshot is being created. And then each time before each code execution, you actually resume the snapshot that has been stored. And you don't have to create the code. Where do you want to keep this snapshot? No, this is automatically done by AWS. It is also possible to use GraalVM native images. So in this case, you are just not using runtime. The typical runtime, you just basically use the custom runtime option. So it is also possible. But obviously, all the deficiencies, or maybe constraints is a better word, all the constraints of GraalVM apply here as well. And yes, one thing that you should really learn about, if you haven't yet, there is actually a library called Power Tools for AWS Lambda, and this library is specifically for Java. I think there is also an equivalent for TypeScript. I'm not sure if it has all the features already, but what it does is this library implements all the typical cross-cutting concerns. So the stuff that you still have to implement, but in this case, it has been codified as a good practice by people who create a lot of this code. It started in the internal team in Amazon, and then it was open sourced again. You can see the address here on the screen. So what kind of cross-cutting concerns? What can it do? So even without popular web frameworks, which typically have observability instrumentation, this one has its own instrumentation. So even if you use just those simple libraries without the framework, you have the instrumentation for tracing, for structure logging, for creating custom metrics, which is nice because you don't have to think about this too much. It it also lets you or simplifies you create or assure the idempotent call of your Lambda functions. And I will show you an example in a second. It can help you with automatic handling of large messages. So when you don't want to push a huge payload actually as an argument to your function, but this payload will go, for instance, as an object to S3, and you will have just the reference to this payload. So it also can automate this for you. And many, many, many more. So feel free to check all the features. So the instrumentation for observability is super simple. These are just the attributes. So in case of logs, it's just one attribute, and here is how it looks like later as data in CloudWatch. So in the observability service. For tracing, it's super simple as well, and then you can very easily integrate it with X-ray or with OpenTelemetry and all kinds of services that accepts OpenTelemetry distributed tracing information. So again, you just use the attribute and you don't have to worry much. Yeah, you can put the annotations in context just like you can see here. The same applies to creating custom metrics. You just give the name of the metric, the unit, and the value, and that's pretty much it. And then, in this case, the visualization also comes from CloudWatch, so it reads it automatically. It integrates automatically. Idempotency is a little bit more sophisticated, I would say. You need to configure it in your initialization part. So the idea here is that you want to avoid the situation that the function, which, for instance, gets some list of parameters, is being run several times, but you already know that with the same set of input, you always will get the same output. So in this case, there may be a mistake, there may be an error, there may be an issue, it may run in an endless loop and generate you like massive cost. So you may actually want to avoid that. So in this case, this small functionality in this library, what it can do, you can configure it and it will just hash the collection of your input parameters and basically cache the result. So if the result is not present in the cache yet, it will run the function and put the result in the cache. But if this hash is already present, if the hash is already present, then it will just return the result. And of course, you can decide how much does the result leave and so on and so on. So, but still, the configuration is up to you, but in some cases, it may save you a lot of money. Containers. Let's talk a little bit about containers, about running Java code, JVM code in containers. So first of all, there was a famous joke, which actually was not a joke, that you can run containers on AWS in more than 17 ways. And probably right now it's more. And the funny thing is that I will start with telling you about one more ways to run containers on AWS. And why so? So there is a service which is called AppRunner, and maybe you haven't heard about it. So what is specific about AppRunner and how does it differ, for instance, from managed Kubernetes? So the idea is, and the reason why I'm talking about it here, is that that's the serverless container service where you don't even have to know what is a Docker file, when you don't even have to create an image. Basically what you do is you just give the reference, this is my repo on GitHub, and this is the branch I would like to work on this environment, and it will do all the magic for you. And why I'm talking about it right now and right here, because obviously it doesn't understand all the programming languages. It only understands few of them, and yes, Java is one of them. So if in many cases, or in some cases, if you really want something super simple, if you don't want to manage infrastructure, if you don't want to manage Kubernetes, if you don't want to know what is ingress, what is service, basically this may be for you. And what it does under the hood is it uses plenty of other AWS services like auto-scaling, elastic load balancing, ECS, Fargate, code build, all this kind of stuff in a completely transparent way. So what you have is you just have the repository, you have the Java code, you just answer a few simple questions in a wizard, and it does all the magic for you. What do I mean by all the magic? It's the stuff that you see at the bottom of the screen. So for instance, like safe deployment, which is in the blue-green deployment, so without the downtime. Obviously, the load balancing between if you have more than one instance of the container and you don't manage the instances of those containers. What you specify is how many requests can one instance handle. So for instance, each instance is optimized for 200 requests per second. So then this service will just use this kind of estimation, and it will scale automatically based on the number of requests that are coming. And yes, all the kinds of other concerns that you see at the bottom, it's automatically handled as well. And it works for Java. And again, when it comes to JVM, as you can see, in some cases, as you perfectly know, in some cases the dependencies are huge. The actual memory footprint is huge, so there are several ways how to optimize Java code, JVM code, when it comes to running it in the cloud. So for instance, you don't pay too much and you don't have to wait too much. For instance, when your Kubernetes cluster decides that, all right, so we need one more pod, but we need to start it, so like 10 minutes. So maybe let's talk a little bit about optimization techniques that will shorten this time. So first of all, this is a no-brainer, and everyone does that, and this is in no way specific to Java and JVM. So we can just compress the image. And that's what many people do, just to make the image smaller. So we can use gzip, we can use zstd, and basically like the code on the screen is enough to do that. But there are smarter ways to do that, especially if you work with JVM. So I'm not sure how many people have heard about Jib. Jib actually was created by Google, but it can be used also on AWS. So the idea about Jib is that in this case, you don't even use Docker to create the image. Actually use Maven to do that. And Jib understands the structure of your project. So what it does, it understands which part is your code, which part is the dependencies. So when it creates the images, actually when it creates the layers, it structures them in a way that, for instance, when just your code changes, only the given layers change. So it's actually much faster to rebuild and download only those layers that have changed. So it's a nice optimization technique, and it can be very easily used in the cloud. Not many people know about this. And again, this is like specific to Java. Another interesting technique when it comes to large images is SOCI, Seekable OCI, basically. So how does it work? The disadvantage of Jib that I showed you just a moment ago, the disadvantage was that you need to recreate your images. So the images that you are creating, the Docker images you are creating before, they are not good for that. You need to recreate them. SOCI is different. You keep your images that you have, and you use the one small tool, snapshotter tool, that creates indexes for your images. What do those indexes contain? Those indexes basically have an indication where a particular file, where the particular functionality, where the particular interesting part is located. So what it means that while your image is being downloaded, but it's not downloaded completely yet, it can already be accessed. So some parts can be already be used while the file is not completely downloaded yet. So it's a nice optimization technique. However, your container runtime, cloud container runtime, has to support it. And the idea is that, yes, in AWS it does. So it sounds like a benchmarking, but yes, can be a very nice gain in container startup performance for large images. But I mean for really large images, more than 200 megabytes and so on, so on. So you should consider it because, again, it's just one simple tool to use. You don't have to change your code. And if your containers are huge, that can make a difference. There's a nice blog post that you can see at the bottom. Another interesting technique that you can do is actually you can build your custom JRE. So you don't have to use the default one. It's very simple. Well, maybe not very simple, but it's simple. You can do this with JDAPS and JLink. I guess you probably already know the tools. So you do it in 2 steps. So first of all, you need to figure out what are the actual dependencies. So you have the application. In this case, the application is store Spring Jar. And this for this store Spring jar, what you do is you create the map of dependencies, and the map of dependencies is put in the file jre-deps.info. Once you have that, then you just create, using JLink, you just create the new customized JRE, which contains only those dependencies which are in the file. So it strips everything that you don't use. So you actually get the smaller size and the smaller footprint. And then, in the next step, what you do, you copy your existing application, you copy your custom JRE that you have just created, and then you run it in your container. So that's yet another trick, like how you can reduce the size, and when you reduce the size, you reduce the time to download it. And how do you reduce also the startup time and the memory footprint for your Java applications? Yes, I said I will mention Crack. So Crack, I'm not sure if you are familiar, a coordinated restore at checkpoint. Basically, it's pretty much the same idea like with the snap start. So the idea is to have some sort of a snapshot. And this is the snapshot of the initialized container, so not the image, but initialized container. And you can use those snapshots to initialize new containers faster. So the trick about Crack is that for now, this is not yet GA. This is not generally available. This is still an experimental kind of feature. So not every OpenJDK distribution does support it. However, there are companies, there are people, well, people do crazy things, but there are some organizations, there are some companies that do run it already in their production systems. You can see some links here. But you need to pick your OpenJDK distribution wisely. So that's yet another way. And this can be useful for you, especially if you, for instance, have a large-scale business in the cloud with not really foreseeable traffic. So imagine that you are running something in, I don't know, social media space. And basically, there's a new celebrity activity. It happens, actually. I work with startups who work in a similar space. And this is something you cannot predict, but your infrastructure is not sufficient. You need to spin up some resources very, very quickly. And for this case, you need such optimizations. Yet another interesting optimization that not everyone is aware. A few years ago, when Apple has released their first M1-powered MacBook Pro, like the word went crazy. Oh my God, this is so fast. This is so nice. And that was also my first thought. But my second thought about what I want that in the cloud. If the ARM processors can be that nice and that fast, so why don't we do that in the cloud? And yes, we do that in the cloud. So there are also ARM processors, processor-powered instances in the cloud. In Amazon, in AWS, they are called Graviton. We already have 4th generation Graviton 4. And they actually make a lot of sense, because for some languages, they can be tricky. Programming languages, I mean, of course. Why they can be tricky? Imagine that you have a language like C or C++ when you have some static and dynamic linking of the code that has already been compiled. In this case, it would mean that this code had to be compiled for ARM specifically. And you know, when you use some libraries, none of those libraries are being regularly maintained and so on, so on. So in some cases, it may not be obvious that you will always get that version and so on. But in case of Java, how does Java work, where it has the JVM, where you are not normally compiling to the bytecode directly, then it makes much more sense, because typically it means that you don't have to modify your code and you don't have problems with the dependencies. There are 2 interesting links here. So the first one, getting started, is just to learn, like, okay, so how do I run ARM in the cloud? And the second one is a porting advisor, which can actually analyze your code, looking for dependencies or some super odd constructs that may be troublesome for such a migration. And yes, we as an organization also contribute ARM-specific optimizations. We do this since OpenJDK 17. So yeah, we do that. Developing in Java. So okay, so we can put code in the functions, in the containers, but in general, when we as developers write some Java code, is there anything specific on AWS that will help us? So there's a relatively new thing which was released, I don't know, like 2 months ago. And before it was called Code Whisperer. You may like recall it by that name. And Code Whisperer, if you have heard about it, it's you are probably associating it with yet another code assistant. So yes, code assistant is a part of QDeveloper. So like GitHub Copilot or Tab9, that's basically that kind of tool. However, QDeveloper promises to be something more. And of course, you need to try it on your own to make your own opinion. And by the way, the personal version of this tool is free. So there is no burden. You don't have to pay. You can check it on your own if you want. So what does it do, except being a code assistant? So it promises to actually be present not just in your IDE, but also in AWS console, in the documentation, in AWS console in mobile, yes, as a bot, for instance, in Slack, and in your CI tools. So what does it do there? And typically when it's present as this blue icon that you can see in top right corner. So what does it do? What can it do? That's what it does in console. So when you go to AWS console, to a cloud console, you can, for instance, chat with that. And chatting is fun, but the interesting thing is that AWS has put there their own internal knowledge base about the development, about good practices. So it basically has customized this model that is used there. And by the way, it's not revealed which large language model is used. So it has customized it with like those 17 years of AWS experience, including knowledge, technical support knowledge base, and so on, which means that it's possible that you may solve your problems, the problems you have, directly by asking the question in the console. What else? Another thing, yeah, I've mentioned there's a code assistant. So it will create code for you. It can help you explain the code, and it's relatively customizable. So it's a matter of taste, whether you like it or not. You know how code assistants look like, so I won't talk a lot about it. But of course, Java is one of the supported languages here. So one of the few supported languages here. This is a very interesting feature, and that's something I like really much. It's called, because I'm in general hooked on the idea of the autonomous agents when it comes to GenAI applications. So it's called Amazon Q Developer Agent. And what it really does is it has the power of transforming your code, for instance, changing, refactoring, creating the plan. However, it uses agents which are trained on very specific tools like OpenRewrite. By the way, someone has already mentioned OpenRewrite, I think in this room in the morning today. So what is OpenRewrite? OpenRewrite is an open source framework, which is a modernization and refactoring framework. So in OpenRewrite, you have like codified good practices, for instance. What should I do to migrate from Java 8 to Java 17? So basically, this agent that is present in QDeveloper knows those techniques. So what you can do is you can ask it, OK, so this is my huge project. We worked on this for 10 years, and we never have time to migrate it to the latest Java. Can you do it for us? Or can you support it? Can you create a plan? And what it does, because it's trained with these agents, which specifically can use OpenRewrite, what it can do, it can simplify it and speed up and actually be very consistent in very tedious work of migrating those files. So personally, I didn't do such a migration. I mean, I did some Hello World kind of tutorial migration, which is not really super representative, but I've seen like some very interesting internal results that they've actually were able to like migrate really huge code bases in literally a few days. So I'm really enthusiastic about this idea, about using autonomous agents. I see like plenty of other applications of such agents, not just for the code modernization. What else? Yes, it can create tests for you. Actually, that's, in my opinion, is quite controversial. I have a slightly different approach to creating tests, and I wouldn't rely on AI to do this for me. But the interesting thing is that actually it doesn't just create the test, but it can test your code, scan your code, or assess your code when it comes to security and good practices and frameworks like, for instance, OWASP and the databases of vulnerabilities. So that's actually quite interesting. And yet another interesting thing is that when you interact with this Q developer in console, it knows your resources. It knows what you have in the cloud. So you don't just ask generic questions. So how do I connect this to that? But for instance, all right, so how many, do I have any instances, EC2 instances, which, for instance, have the CPU load below 10% for the consecutive week, because maybe someone has orphaned them and forgotten about them. So that's actually very interesting. And my favorite feature, which may not be like super good looking, but it's actually very useful, is troubleshooting, especially networking troubleshooting. So for some reason, one of my services cannot reach the other one. It doesn't work. It just doesn't integrate. So I'm checking my root tables. I'm checking my knuckles. I'm checking my security groups. What have I broken? Like, what's preventing me from connecting those two things? So typically, there is a lot of debugging, troubleshooting, and experimenting. And in this case, you can ask GenAI. And actually, it's quite good in figuring out what you're missing. Of course, then it's the question if you really want to add what's missing, because maybe it's missing for a purpose. Anyway, yes, it's super important. It knows your resources, and it also knows your bills. So you can explore and dive deep into what you are paying for and, for instance, optimize your cloud cost. Because right now will be easier because you can do this in the conversational way. Code Guru, that's an old service, so very, very quickly. It has two parts, Reviewer and Profiler. Frankly, I haven't used those two. Reviewer is super controversial. Why so? Because Reviewer is actually supposed to somehow support the reviews of your code. So it comments your code and it provides you suggestions based on good practices. So I haven't tried that, to be honest. But it works with Java code. It's one of the supported languages. So feel free to take a look. Profiler is the JVM aware profiler. So it's you cannot see it because actually the characters are too small, but this is actually there's some JVM code. So it helps you to understand the memory footprint and to analyze basically what's going on. So there's the cloud profiler for the code that is deployed already in production. Okay, stuff that do not fit any of the categories I've mentioned before, but may be useful. First of all, everyone loves infrastructure as code. Why so? Because we love to be very specific about what we have in the cloud. And yes, there are many frameworks, there are many tools. There is CloudFormation, there's Terraform, Pulumi. Not that many people have heard about CDK. CDK it has already a few years, I think, and it's yet another tool by AWS for the infrastructure as code. But why do I tell you about this right now? Because the idea is that you specify the infrastructure you want in your favorite programming language, which means that you can specify in Java, for instance, what would you like to deploy. And the interesting thing that CDK comes in layers. So the layer one is basically the resources just like they are defined in CloudFormation. So in a very atomic way. For instance, that is the load balancer. That is EC2 instance. That is ECR image. So basically, there's a very low level of abstraction. So you have to create a lot of code. Level 2 is optimized for your level of programming. So it utilizes your expressiveness of your programming language. So simplify some things. But things get really interesting at level 3 and above. Why so? Because come on, this is Java. So in Java, you can compose it completely freely. So it means that in this level 3 library, there are constructs that represent whole design patterns. For instance, you don't have to specify, okay, so I want an ECS task, and I want it on Fargate, and I want a load balancer, because typically, those things typically come together. What's the point of having the same thing in a few containers if you don't have load balancer on the top of that? Do you want somehow manually pick the container that you would like to call? No, of course not. So it's Java. So in Java, you can compose those things. So those libraries with composed good practices and design patterns, this is already done for you. And this is done as a part of CDK, and it's available in your favorite language. And the funny thing is, and we are making a huge loop, that it would not be possible without the tool that I've mentioned in the beginning, without Smithy. Because Smithy is actually a bridge which creates this code for you in your favorite language. And the good news, and why you should care, is that this is actually a guarantee that your C version of CDK, so Java version of CDK, won't get outdated just because AWS doesn't have time to work with the Java client. No, because it's automatically generated based on those definitions in IDL. Yeah, so some L3 plus constructs, for instance. In this case, yes, Lambda REST API or application load balancer on the Fargate service. Minimum number of parameters, and just the whole design pattern is being deployed. Concluding, a few interesting things. Java actually has all Java frameworks I know, which are not that many, but I know some, have a great support for OpenTelemetry. So in this case, on AWS, there is a dedicated AWS distro for OpenTelemetry. So it's super easy to integrate it, just by using this distro, just by specifying to use this distro, and then you have the automated instrumentation of your favorite framework. And you can use it with third-party tools. You can use it with AWS equivalents. You can use it with basically whatever you want, whatever is compatible with OpenTelemetry. And if you, for instance, actually just have some Java code and want to use it with AWS telemetry, it's also very simple. Here's one example. You can use, for instance, collectd to send JMX data and integrate it with the AWS native observability tools. Easy stuff. And then you just see it in CloudWatch. OK, few resources. So if you want to take a look, all this content and much more is available in this free training. So if you follow this link, it's called Java Immersion Day. And yeah, there are plenty of small workshops that you can run on your own just to try those things. That only the things that you find useful. You don't have to do all of that. Same thing, but specifically for Lambda. If you want to run Java on Lambda, there's a workshop with all of those optimizations, all of those techniques, and you can try them on your own. There's yet another guide for the replatforming of your Java code. If you, for instance, are running some legacy database, not database, code base, and you want it to run in the cloud. And finally, if you are more interested, even more interested in the container optimization, there is a whole white paper based on that. It's a very interesting topic. And especially for the JVM developers, if you are struggling with the size of your dependencies, size of your images, that's really a battle that can be won. Thank you very much. That's everything I had to prepare for you today. Again, if you have any questions or if you would like to talk about Java on AWS, AWS in general, or CTO Morning Coffee, feel free to reach out here in the corridors or using any of this contact information. Thank you very much and enjoy the rest of the conference.